One of the most famous disasters in history was the sinking of the RMS Titanic. The story of this grand steamer, commissioned, designed and built by Harland and Wolff for their Olympic-class ships, has fallen into history as the greatest tragedy of the early 20th century. Much of her story is well known to most scholars and enthusiasts, but something many people overlook when viewing this marvel of technology are her massive steam engines. These massive propulsion plants generated nearly 60,000 horsepower combined. Titanic's engines consisted of 2 triple expansion reciprocating steam engines and 1 low-pressure Parsons turbine. All 3 of these engines combined rotated the massive propellers to give Titanic a maximum speed of nearly 24 knots through the cold Atlantic waters. This masterpiece of human engineering and her sister ships, the Olympic and Britannic, were the biggest ships of their time. Titanic was launched on April 10, 1912, headed for New York. On the night of April 14th and 15th, she struck an iceberg and sank only 2 hours and 20 minutes after the collision. When she foundered, many questions came to mind. How could an unsinkable ship be doomed by a mere iceberg? How could the captain let this happen? Why did so many people die? The answers have since surfaced, but still, many don't realize just how well Titanic did to withstand the whole breach. Many also ignore the splendor that was her propulsion system and how hard it worked to keep passengers comfortable and as safe as possible. Titanic's story began when her keel was laid on March 31st, 1909. Designated Hull 401, Titanic's massive iron plates were riveted together by 4-man rivet teams, giving shape to her iconic hull. Almost 4,000 of Harland and Wolff's workforce was split between the Olympic and Titanic. During her time in dry dock, Titanic's hull took shape, building her watertight compartments, her engines, crankshafts, boilers, and other framing required for her operation.
Titanic's hull consisted of a double bottom, 15 watertight compartments, and passenger quarters. The watertight compartments reached up to E-deck and consisted of 6 boiler rooms, 2 engine rooms, and 6 cargo holds. If a breach were to take place, the designers thought, the ship would stay afloat. Captain Edward J. Smith is known to have remarked that if Titanic were cut into 3 separate pieces, she would still float freely.
What the engineers did not account for was the unlikely event of her first 5 compartments being breached. This caused the bulkheads to be dragged below the waterline, thus dragging the rest of the ship down as well. After her partial launch on May 31st, 1911, she was taken back to dry dock to have her propellers mounted. These huge cast iron propellers were each 23.5 feet in diameter, with the central propeller only 16.5 feet across. It took crews patience and time to get these mounted, by easing them onto their tapered tail shaft, utilizing railroad sleepers. After 3 years, hard iron work, and masterful craftsmanship of the staterooms, she was finished. She launched successfully, and now it was up to the power plant to work hard, keeping the passengers content, and headed for New York. Titanic was a marvel in technology. Not only for her size at 131,000 tons, but for her steam system. Boiler rooms 1 through 6 contained 24 double-ended boilers and 5 single-ended. These were fed by 159 furnaces, which consumed 850 tons of coal per day. From here, the smoke was carried out of the forward 3 smokestacks, the 4th of which being air intake for the engine room. The ash produced would be carried by wheelbarrow to the ash ejectors located in each boiler room. High-pressure water would carry the ash out of the chute and into the sea. The high-pressure steam at 215 psi and 394 degrees Fahrenheit was carried directly to the 2 main engines of the ship. The 2 massive triple expansion reciprocating engines were 63 feet long and propelled the larger of the 3 propellers. These were commissioned and designed by Harland and Wolff for their great ships, but much of the designs were taken from other steam engine manufacturers of the day. The steam would enter the high-pressure valve, exit into the intermediate pressure valve, out into the low-pressure valves, and to the low-pressure Parsons turbine which drove the smaller central propeller. Because of the configuration of the turbine, only the two reciprocating engines could be put into reverse, leaving the central propeller inert for aft movements. From the engines, the energy was transferred to the crankshaft and propellers, which pushed and churned the water, forcing the ship forward. Because the ship was so massive and the energy generated so powerful, thrust block collars were installed around the crankshafts to keep them from drifting forward and pushing the cylinders out of alignment. From here, the steam traveled at only 1 psi and 102 degrees Fahrenheit to the two condensers where it was recycled back to the boilers. The main condensers ran the steam through pipes which had cold sea water surrounding them. This would ease the separation of water and air to boil again. This closed system only added to the grandeur and invincibility of Titanic. People's perceptions of the ship only grew as the ship continued being built. The maiden voyage was met with a grand reception as 914 passengers boarded at Southampton on April 10th. After taking on the rest of the passengers in France and Scotland, Titanic had 2,220 people aboard, including 900 crew. Because of the design of the propulsion plant, passengers were at ease and quite happy with the low vibration and quiet steam engines chugging away below. On the fateful night of April 14th, 1912, at 11:40 p.m., the order for hard A starboard and engines full astern rang through the ship. The chief engineer ordered the furnace dampers closed and engines slowed to reverse them. Though First Officer Murdoch tried to make these orders in time, the ship hit the berg at nearly 21 knots, causing rivets to pop, and seams below the waterline were created along the forepeak, holds 1, 2, and 3, and boiler room 6. This moment marked the doom of Titanic, and 1,500 of her passengers and crew. When Titanic made her final plunge, the world was left in curiosity about her fate for 70 years. Titanic succumbed to the sea, but nobody was sure in what condition she lay on the bottom. Could she be recovered? Was she in as pristine condition as the night she sank? Upon rediscovery, the first thing to be found of Titanic's wreck was a single-ended boiler from Boiler Room 1. Many expeditions have taken place since Robert Ballard rediscovered Titanic. Many were amazed and disappointed to see Titanic in two pieces on the ocean floor. The major focus of expeditions to the Atlantic seabed are the debris field and bow section of the ship. Since the stern is in such a mangled and unrecognizable state, not many study what is left. But what is the destiny of this great ship? Now, the best course of action is to protect this relic from frequent visits. Already the crow's nest has been lost. The warning bell scavenged along with many passengers' belongings. Though these are all wonderful pieces for study, the great ship continues to rot away on the seabed, and only observation from a distance will allow her to survive as long as possible as a tombstone for those who died that cold night all those years ago.